So we'll continue in the 2-degree freedom system example. Next is a torsional vibration system. Torsional vibration system. Now let's say we have a shaft to the end of the shaft. Two discs are connected. Moment of inertia, the first disc is, let's say, J1. Moment of inertia of second disc is J2. Torsional stiffness of the shaft is Kt. If you look at the side view, it will be like this. Let's say the angular rotation of the first disc is theta 1 and angular rotation of the second disc is theta 2. Length of the shaft is L. Length of the shaft is L. Okay. So as we said, let your J1 and J2 are the moment of inertia of rotor 1 and 2 respectively. Kt is the torsional stiffness of shaft. Okay. Then theta 1 and theta 2 and the displacement, angular displacement, you can say angular displacement of rotor 1 and 2 respectively at any instant. At any instant. Okay. Now we take a term theta and uh, twist on the shaft will be equal to theta 2 minus theta 1, assuming theta 2 greater than theta 1. And the torque exerted by shaft in the direction of rotation on J1 is Kt theta 2 minus theta 1, and same torque is exerted on J2 in opposite direction. In opposite direction. So the differential equation of motion of R J1 theta 1 double dot is equal to KT theta 2 minus theta 1 and J2 theta 2 double dot is equal to minus KT theta 2 minus theta 1. Let's say this is first set of equation, or we can write this equation R as J1 theta 1 double dot plus KT theta 1 is equal to KT theta 2 and J2 theta 2 double dot plus KT theta 2, this is theta 2 is equal to KT theta 1. Okay, let's say this is second equation. Now assuming the solution for principal mode of vibration as theta 1 is equal to beta 1 sin omega t and theta 2 as beta 2 sin omega t. Let's say this is equation 3. So from equation 3, we have theta 1 dot is equal to omega beta 1 cos omega t and theta 1 double dot is equal to minus omega square beta 1 sin omega t and theta 2 dot is omega beta 2 cos omega t. Theta 2 double dot is minus omega square beta 2 sin omega t. Let's say this is equation 4. Okay. Now substitute these values in the preceding equation. We'll have j1 omega square beta 1 sin omega t plus kt beta 1 sin omega t is equal to kt beta 2 sin omega t, okay, and minus j2 omega square beta 2 sin omega t plus kt beta 2 sin omega t is equal to kt beta 1 sin omega t. So let's say this is equation 5. Equation 5 we obtained by substituting the value of theta, theta dot, theta double dot in equation 2, right? So now we can further reduce this equation to minus j1 omega square plus kt beta 1 is equal to kt beta 2 minus j2 omega square plus kt beta 2 is equal to kt beta 1. So let's say this is equation 6. Okay. Now the two ratios obtained from equation 6 are beta 1 by beta 2 will be kt divided by minus j1 omega square plus kt, and the second ratio beta 1 by beta 2 will be equal to minus j2 omega square plus kt divided by kt. Let's say this is equation 7, this is equation 8. Now equating 7 and 8, we have kt divided by minus j1 omega square plus kt is equal to minus j2 omega square plus kt divided by kt, right? So we'll have j1 j2 omega to the power 4 minus j1 omega square kt minus j2 omega square kt plus kt square is equal to kt square. So if we reduce this further, we'll have omega square taking common, we'll have j1 j2 omega square minus j1 plus j2 of kt is equal to 0, because this will get cancelled out. So finally we'll have omega n1 will be 0 and omega n2 will be kt j1 plus j2 divided by j1 j2 whole root over. Okay. Two sets of natural frequency we got, which gives beta 1 by beta 2 as plus 1, and the second mode we have beta 1 by beta 2 is minus j2 by j1. Okay. This is equation 9 and this is equation 10. Okay. So the corresponding mode shapes, if you draw, mode shapes are the first case This is beta 1, this is beta 2 for omega n1 equal to 0, and for the second case, this will be beta 1, this is beta 2, okay. This length is L1 and this length is L2. So this is for omega n2. Omega n2 value is root over kt j1 plus j2 divided by j1 j2 divided 2 mode shapes. So in the subsequent class we will solve some problems.